Hello learner, welcome once again to Manifested Online Classes. My name is James Kenyani. We are still going to continue with our lesson on area approximation. Today we are going to look at the trapezium area or finding area under curves. So the lesson is trapezium formula of finding area under curves. So the objective of the lesson is to enable the learner to derive trapezium rule. So the main objective of the lesson is to enable the learner to derive the trapezium formula of finding area under curves. So why is the interest trapezium area? Looking at figure C, this is a curve given by that function. It can be y is equal to x cubed or y is equal to x squared. So under the curve, we have a shaded area which is bounded by the limits here from this limit to that limit, and it is divided into equal strips. So those equal strips compiling up their area will give the area under the curve. So if you look at the shape of the strips, they look like trapezia. They look at several trapezia. That's why we get interested in using the trapezium rule. Before we get there, we should first of all look at the formula for finding the area of a trapezium. Before I move ahead, at this stage we know that a trapezium is a quadrilateral having two parallel sides. The other two sides are not parallel. A pair of the sides in a trapezium are parallel. So if that is my trapezium, so we find there are two trapezia there, the first trapezia and the second trapezial. What is characteristic in both the two? They each have a pair of parallel sides, and there is a distance which is the height between them. There is also a height there. So area of each of the trapezium is given by a half, it's given by b plus a over 2, the average length of the sum, a plus b, b plus a over 2 times the height, which is a half a plus b times h, where h is the distance between the parallel sides. So in words, you can say it's equal to, it is equals to a half the sum of parallel sides times the distance between the parallel lines. So that is what we get, a half the sum of the parallel sides times the distance between the parallel sides, which is given by h. Let's relate it to the area under this curve. So that is the curve there. This is the area. The shaded area is under that curve. And that area, I said the area under the curve is made up of 7 trapezia. These lines you see that denote the function of the curve, y0, y1, 1, 2, 3, 4, 5, 6, 7 are called the ordinates. y0, y1, y2, y3, y4, y5, y6, and y7 are called ordinates, which happen to be, which are the parallel sides of the trapezia. So learner, those lines, the length y0, y1 up to 7, those are the ordinates. And h is the width. So you note, learner, these ones are called the ordinates. Ordinates. Those ones are called the ordinates. And the width is h. So when we retreat back here, we want to find the area of each of the trapezia. Area of each of the trapezium. Total area we want to find the total shaded area or area under curve. We want to find area under curve is equal to area of all is equal to area of all the trapezia. So we can get the area of each of the trapezia because we know for this strip, these are the two parallel sides. For this strip, like that. So we start getting that area. Start with the first strip. I have the sum of parallel sides. We shall come and have, for the first one, I have y0 plus y1 times h, which is the width, plus, we come to the second one, a half y1 times the width h. We go to the third one. We go to the third one, a half y2 plus y3 times the height. We go to the fourth one, a half y3 plus y4 times the width, a half sum of parallel sides times the distance between them. We go to the fifth one, plus a half y4 plus y5 times the width h. Those are 5. 1, 2, 3, 4, 5. We still have 2 to go. Plus a half y5 plus y6 times the width h. We have the last one. We have the last one, which is a half y6 plus y7 times the width. So we come and factorize. What is common in both of the two, a half and h? A half and h. So this is the same as saying a half h, a half h. I've got it out. A half h. Then we have y0. We go step by step. We have y0 plus y1 plus y1 plus y2 plus y2 plus y3 plus y3 plus y4, isn't it? Y4 there plus another y4 here. This has already been factorized. Y4 plus y4. The same will happen to y5. Y5 plus y5. Y5 plus y5. You'll also have y6 plus y6. And at the end, you'll have plus y7 plus y7. So we'll continue on this side. Let's continue with that. What is happening to the final formula? Learner, after factorizing. After factorizing, we are remaining inside with y. At least the others, the mid ones, they appear twice. But the first one and the last one appear once. The first one and the last one appear once. So, on factorizing, you'll get a half h into brackets, a half h into brackets, y0 is appearing once. Y1 is appearing twice. Y2 is appearing twice. Y3 is appearing twice. Y4 is appearing twice. Y5 is appearing twice. Y6 is appearing twice. And Y7 is appearing once. So what do you notice? Y1 to Y6 are the mid ordinates. The mid ordinates. They are the mid ordinates. They are the mid ordinates. So the formula comes to a half h into y plus 0 plus y plus 0 into twice y plus 1 and you add up to a certain limit, which is y into n plus minus 1 close brackets, because you are adding up to 6, so it will be n plus 1, then plus y into n, where n is the number of strips. So in our case it was 7. It was 7, and the last one we had double was at 6. So you can also come and say it is equals to a half the width of strips into brackets. This is the beginning. You can talk of the beginning. You can talk of the beginning. Ends plus twice mid-loose. That is a simple formula for the trapezium rule. That is a simple formula for the trapezium rule. A half the width of this strip. Then you add the ends. The ends is y0 and y7. The ends is y0 and y7. That will give you the trapezia formula. So the trapezium formula is equal to a half h into y0 plus twice y1, you add up to yn minus 1 plus yn plus yn. So you'll add up to that one. So this is a half into that plus yn. That one comes to be simplified to it comes to be simply to a half the width of the strips into ends plus twice mid-loose. These are the mid-loose. Y1, 2, 3, 4, 5, and 6. So shortly, let's go through what we've gone through. We first of all started by the formula for a trapezium. Then we realized area under a curve, the area is divided into strips. So we took each of the strips to be a trapezium, and we got its area differently. On factorizing, we found that the first ordinate and the last ordinate appeared once. Then the middle ordinates appeared twice. The middle ordinates appeared twice. So you come on and say where h is the width of the strip, and n is the number of strips. We are taking of the number of strips or trapezia. So that is what we call the trapezia formula for area under curves. That is the trapezia formula for area under curves. So you'll come and for the assignment, so you'll derive the trapezia formula for finding area under curves. Just going through to understand the formula before we start using it. So thank you very much for the audience, and let's meet in the next lesson. Bye-bye.